I'm Anil Kumar, and now let's explore polynomial functions. To begin with, let's find reasons why some functions are not polynomial functions, right? Here we have two examples, and we need to find reason for functions not being polynomial functions. So the first one is explain why the sinusoidal function is not a polynomial function, right? So sinusoidal function. If you look at sinusoidal function, it's a sine graph like this, right? It's kind of like this. It goes forever, right? Like this. So we can just go for both the sides, correct? So as you can see, it is a smooth curve. And it meets all the criteria for a polynomial function, right? But why it is not a polynomial function, that is the question. Now, one reason is that, and that's a very critical reason, that it is bound on both sides. Bound on both sides means it has a maximum, absolute maximum, as well as absolute minimum, right? Bound on both the sides, right? It has both absolute maximum and minimum, right? So that is troublesome. A polynomial function, however, can be bound only from one side, right? That is the reason that it is not a polynomial function, right? Remember, we could have a polynomial function which is bound on one side. For example, we could have a function like this, right? So it is bound on the lower side, right? But normally, polynomial functions, the end behavior is that it extends to infinity, right? And the end behavior here is that it is not going to infinity. That is one criteria. And second condition we could say is about the end behavior. Well, there could be many reasons, but I'm trying to give you two very critical reasons. The end behavior is that as x approaches infinity, plus infinity, or as x approaches minus infinity, y should approach plus or minus infinity, right? For any polynomial, y has to approach plus or minus infinity. Here we are not very certain about. It's a periodic wave. We don't know what really happens at x approaches plus or minus. We know it has an upper and lower bound, so it is never more than plus or minus 1, correct? We know it will never reach plus infinity or negative infinity. Therefore, it is not a polynomial function, right? So these are two great conditions which we can always put for sinusoidal wave not being, or sinusoidal function not being a polynomial function, right? So one, it is bound from both sides, and second is end behavior, that is as x approaches plus or minus infinity, y does not approach plus or minus infinity, right? Now the second question is, explain why an exponential function is not a polynomial function, right? Now if you look at exponential function, then they are kind of like this. Now one thing is there, if you see the right side of it on the first quadrant, then as x approaches positive infinity, y approaches positive infinity. So this part looks like a polynomial, but here is a problem, right? So the problem here are two. One is it has horizontal asymptote. Now polynomial functions do not have any asymptote, right? So polynomials do not have any asymptote. That is one thing. And second thing is the function does not approach positive or negative infinity. End behavior, right? That is what it is, end behavior. So as x approaches negative infinity, y approaches 0, which is kind of horizontal asymptote, right? So either way you could explain that polynomial will approach positive or negative infinity. That is kind of very important. But here, the end behavior, x approaches negative infinity, y is approaching 0, not plus or minus infinity, right? That is kind of a reason why this is not a polynomial, right? So this graph is not representing a polynomial. Well, algebraic solution is exponential function is a function which has an x, any constant here, let's say b to the power of x, right? Now, that is algebraic reason for it not being a polynomial function. That is, exponent is a variable, right? It changes, variable, not a whole number, right? It is not a whole number. It could be any number, right? Any real number, but it's not a whole number. It's not a fixed whole number. That makes it troublesome, and that's why it is not a polynomial function. Do you understand that part? So these could be good reasons to explain why these functions are not polynomial functions. Thank you.